This next section, we're going to graph another function called the logarithmic function. So we know that since it's a function, it's going to pass the vertical line test, and for every input, there's going to be exactly one output. So let's start making this graph, log base 3 of x, by making a table of values. So I'm going to put something in for x and see what I get for y, or in this case, we've called it f of x. So just like with exponential functions, I want to be strategic about the numbers that I try. So the numbers that I put in for x, I want to put things that make this thing simple. So probably the most simple thing in logs is when this base value and the value where x is are the same number. So I'm going to start by putting 3 in place of x. I know that when I have log base 3 of 3, so when the base number and this number are the same, it's always 1. So that's why I want to choose that number. The next number I want to choose would be another multiple of 3, like maybe 3 squared. Because when I put in 3 squared, or 9 for x, the answer is going to be 2. And I'll show you how I get those, and we'll talk more about how those answers would happen when we do properties of logs. But let's go ahead and type this in our calculator, and we want to choose log base 3 of x. So on the calculator, I'm going to push math, and then go down and find the log base, which is this, and then I'm going to push 3. And then I'm going to put x here. Well, I guess I better go back to y equals to type this in. So I'm going to start. Let me zoom out here so you can see what buttons I'm pushing on my calculator. So I'm going to start. I want to type in log base 3 of x, and then I want to look at the graph. So to get the log to come up, I don't want to push this log button because that would be the common log base 10, and I want to do base 3. So I'm going to push in math, and then scroll down until I see the one that says log base, and then I'm going to hit enter. And then I want to put a 3 here and an x here because I want to look at the table of values for this. Now, if your calculator doesn't have this button, I'm going to show you in just a minute how you can do it on the other calculator. So then I'm going to hit graph. Notice the graph kind of looks like the square root curve, but what's really happening is this graph is getting closer and closer and closer to this line, but never touching. We can see that if we go to the table. You see how at 3 we had 1, and then the numbers keep getting smaller until at 1 we see 0, but anything before 0 we get an error. So I'm going to go ahead and put that on here. I want 1, 0, 0 is an error, so I can't put 0 in for x, and I can't put anything smaller in for x either because I always get error. Notice that at 1 I get 0, at 3 I get 1. Let's go down to the next multiple of 3, 9, you get 2. Let's go down to the next multiple of 3, which is 27. We get 3. So the best numbers to put in are the ones that are multiples of 3. So let's go ahead and graph this. Zoom back in. So I've got the point 1, 0, 3, 1, and 9, 2. But everything beyond that is going to just be a fraction. Gets closer and closer to 0, but it never touches. So it looks something like this. So what that tells me then is if I can't put 0 in for x, this has to be the asymptote. So the asymptote for a logarithm is a vertical line at x equals 0. The domain then starts at 0 but doesn't include 0 and goes to infinity, and the range goes from negative infinity to infinity because it starts down here and it keeps going. I could also talk about some other properties of this graph. I could talk about this end. This end, x is approaching 0. It's getting close to 0 as y approaches negative infinity. This end, x is approaching infinity as y approaches infinity. It looks something like that. So let's think about here then the inverse of that same function that we just talked about. So we know that the inverse of a logarithm is an exponent. So I'm going to take this equation, and to find the inverse, I'm going to switch x and y, and then solve for y. So to take it out of log form, this is the base value. It becomes the base on the other side. So 3 to the x equals y. So if I graphed this one, if I made a table of values, if I put 0 in for x, I would get 1. If I put 1 in for x, I would get 3. If I put 2 in for x, I would get 9. If I put negative 1, I would get 1/3. So you can see how the x and the y are just flipped. On this graph, it's 1, 0. On that graph, it's 0, 1. 3, 1, 1, 3. 9, 2, 2, 9. So these would be inverse functions. In fact, if I drew in the line y equals x, this would be a reflection like this. So you can see how they're inverses. So an exponent function is an inverse of an exponent. An exponential and a logarithm are inverse functions. If we talked about this exponential function, the domain would be negative infinity to infinity. The range would be 0 to infinity. And the asymptote would be at y equals 0 because I hadn't scooted up or down. So let's do a couple more examples here. I think I'll start and stop the video here.